Hello everyone. We are solving question number 18 of GATE 2018 Chemical Engineering paper, and the subject is process control and instrumentation. The question is, a first order process having a transfer function Gp is equal to 2 upon 7s plus 1 is controlled by a proportional controller with a gain of 3.2. The process time constant is in minutes. Addition of the integral control action with an integral time constant of 5 minutes leads to an increase in which of the following option. So over here we are having a process, and then in the first case we are using a proportional controller. Let's consider if y is our input. So we are showing this controller transfer function at, let's say, GC. The process transfer function is GP. So we will be having this measuring element and blocks corresponding to this final control element also, but let's just consider it as one, and it will be same in both the cases. So initially we are having a proportional controller with a gain of 3.2, that is GC is equal to KC is equal to 3.2. Now for this we can write the closed loop transfer function as G of S is equal to GC GP upon 1 plus GC GP. So we can replace the value of the transfer function of this process, that is GP, and the value and the transfer function corresponding to the controller, that is GC, and we will be having GC is equal to G of S is equal to, that is 3.2 into 2 upon 7s plus 1 upon 1 plus 3.2 into 2 upon 7s plus 1. So this will become 6.4 upon 7s plus 1 upon 7s plus 1 plus 6.4 upon 7s plus 1. That is, for proportional controller, the transfer function will become 6.4 upon 7.4 plus 7s. Over here we can see that the order is 1. This we have only term corresponding to this S. Now what we are doing is we are adding an integral control action to this controller with an integral time constant of 5 minutes. That is basically, initially it was P controller, now we are using this PI controller. So for PI controller, the transfer function will become Kc 1 plus 1 upon tau s, and this value of Kc will remain same as 3.2. The value of tau I we have been given, that is the integral time constant, is 5 minutes. That is 1 upon 5s. Now for this PI controller, we will be finding the closed loop transfer function, and it will becomes GC GP upon 1 plus GC GP. So it will become 3.2 1 plus 1 upon 5s into 2 upon 7s plus 1 upon 1 plus 3.21 plus 1 upon 5s 2 upon 7s plus 1. Now we need to simplify this to find the final form of the transfer function. This will become 3.2 1 plus 5s 2. Over here we will be having 5s 7s plus 1 plus 3.2 into 2 will be 6.4, 1 plus 5s. So that is, we can write, finalize this as 6.4 into 1 plus 5s on the denominator will be 35s square plus 5s plus 6.4 plus 6.4 into 5, that will become 32s. So the final transfer function for this PI controller will become 6.4 into 1.5s upon third upon what? Okay, we are having 35s square plus 37s plus 6.4. That is 35s square plus 37s plus 6.4. Now over here, the denominator has an order of 2, that is n equal to 2. So basically, by introducing an integral action to this proportional controller, we are increasing the order by 1. So from the given options, we have been asked that addition of an integral action with an integral time constant of 5 minutes leads to an increase in the order of the closed loop system. So option C, as we saw that the order for proportional control to PI controller increased by 1. That is, the order is increasing. So option C is the correct answer.